video ini, saya akan menjelaskan tentang Byte Endian. Apa sih Byte Endian dan bagaimana cara kerjanya? Tetapi sebelum saya menjelaskan, kita lihat dulu dari cuplikan video di YouTube.
In this video, we're going to introduce some ways in which multi-byte quantities are stored in memory. This is called byte ordering, and there are two different standard byte orders called Little Endian and Big Endian. First of all, recall that a computer memory is just a large array of bytes, that is, 8-bit quantities. Indices into this array are typically called addresses and run from 0 to some large positive number. When we say that value V is stored at address A, we mean that the bit string representing V is stored in consecutive byte-sized memory locations beginning at address A. Thus, for example, if we say that the 32-bit integer is stored in memory at location 100, that really means that the 32 bits, or 4 bytes, are stored in locations 100, 101, 102, and 103. The only question is, what part of the 32-bit quantity is stored at each address? That's where Big and Little Endian come in. Suppose we're storing the following 32-bit integer. To make it easier to represent, let's write it in hexadecimal or hex notation. Recall that each hex digit corresponds to 4 bits, so 2 hex digits represent 8 bits or 1 byte. This number can be divided into 4 byte-sized quantities as follows. We say that the digits on the left end are more significant than those on the right because they carry more weight. That is, in our standard positional notation, they represent multiples of higher powers of 16. Thus, the most significant byte in this case is 1, 2. The least significant byte is 7, 8. Suppose we want to store this 4-byte quantity in memory starting at location 100. There are two obvious ways to do this. We could store the bytes in successive locations from least significant to most significant, or from most significant to least significant. Little Endian byte ordering means that we store a multi-byte quantity in memory starting with the least significant, or the little end. Let's illustrate. Given our 4-byte integer, we start with the least significant byte and move toward the most significant. Load each successive byte into the next address until we're done. That's Little Endian. To the human eye, Little Endian sometimes seems backwards, since the bytes in memory are not in the same order in which we typically write numbers. But don't worry, the computer doesn't get confused. For Big Endian, on the other hand, we start with the most significant, or big, end of the integer, and work toward the least significant end. Again, we load the bytes into successive addresses, beginning with the most significant byte and continuing until we're done. And that's really all there is to it. Some machines use Little Endian, while others use Big Endian. Most specific machines stick to one or the other. However, there are some machines, MIPS in particular, that can be run in either mode. Note that byte order is only relevant when storing in memory a multi-byte quantity, such as a 4-byte integer or an 8-byte double. Byte order is not relevant when storing individual byte-sized quantities, as in C string data. A string in C is a list of individual ASCII characters, each of which is 1 byte long. Byte order also is not relevant when storing, say, a 4-byte integer into an 8-byte register. The register is big enough to hold a quantity without reordering the bytes. Finally, when doing arithmetic or printing out a multi-byte number, the machine reassembles the bytes in the right order, and in most cases, the programmer doesn't really care about the byte ordering. There are a few cases, however, where byte order matters. When viewing the byte contents of memory, for example, when looking at machine code, the byte order may be visible. Byte order also may be relevant when transferring data over a network from one machine to another, especially if the two machines use different conventions. Most data transfer protocols take this into account.
Oke, setelah kita lihat dari cuplikan video, saya akan menjelaskan singkat saja, yaitu dari Big Endian. Yang pertama yaitu apa itu Big Endian. Jadi Big Endian adalah pemrosesan byte, urutan byte yang disimpan pada memori komputer. Seperti contohnya yaitu pada memori V itu disimpan pada alamat address A. Oke, kemudian ini ada contohnya. Oke, jadi dia punya cara kerjanya itu seperti begini. Ini untuk Big Endian sendiri yaitu nilai yang paling signifikan ditaruh pada address yang pertama, yaitu contoh addressnya itu address 100, dan yang paling tidak signifikan yaitu address 103 dengan nilai 78. Oke, jadi itu Big Endian. Kemudian ini kesimpulannya. Jadi Big Endian merupakan urutan byte di mana byte yang paling signifikan atau nilai terbesar disimpan di alamat memori terkecil, dan byte yang paling tidak signifikan atau nilai terkecil disimpan di alamat memori terbesar. Terima kasih.